This is the amazing high-torque flip gun, the first tool in the world to combine lightning-fast rundown and removal of nuts and bolts with calibrated torque and raw power to handle any bolting job faster, safer, and better than ever before, all in one tool. Unlike air impact wrenches, which hammer the bolt with uncontrolled force and high noise and vibration, the flip gun is a precision torque multiplier which produces consistent and measured power on bolt after bolt without the vibration and noise. Listen to the flip gun in action. It is operated by a pistol grip trigger and features a directional control switch for tightening or loosening, a speed selection arm for high and low speeds, and a safety switch to protect the operator from pinch danger. Let's see how the flip gun works. Before we begin, because we will be handling high-pressure air and heavy and sometimes sharp metal implements, we should first put on our personal protective equipment. At a minimum, this should include safety glasses with side shields, sturdy gloves, and steel-toed shoes. Of course, job conditions and local work rules may require other safety items such as hearing protection, face shields, hard hats, and fire or chemical-resistant clothing. Nothing is as important or as urgent as your safety. Check the condition of the hoses, connectors, and the general condition of the air regulator and tools for any obvious damage. Any defects must be corrected before pressurizing the system. For optimum performance, the flip gun needs a clean, dry air supply of 30 cubic feet per minute at 90 pounds per square inch. The supply hose should be connected to the input side of the pressure regulator assembly with any connector compatible with your air system. Connect the air hose to the output side of the regulator and snap on the flip gun with a quick disconnect coupler. The air control assembly, or FRL, consists of a filter, a pressure regulator, and a lubricator. Do not operate the flip gun without this FRL unit in the airline, as serious damage to the tool will result. The job of the filter is to remove any debris or water from the air supply. The filter can be drained as needed with the valve on the bottom. The regulator meters input air pressure accurately, controlling the torque output of the tool. The lubricator's job is to introduce a fine mist of oil into the airstream to lubricate and protect the internal parts of the tool against corrosion or damage. Depress the detent and twist the clear plastic reservoir to remove it. Fill it to the indicator mark with a quality air tool oil. With air flowing to the tool, you will be able to see drops of oil form inside the clear plastic knob on top of the lubricator. Unscrewing this knob increases the oil flow, and screwing it in decreases the oil drops. Adjust the flow to approximately 1 drop every 10 seconds. The genius of the flip gun is its built-in dual-speed capability that is controlled by simply and quickly shifting the speed selection arm from high-speed rundown to low-speed torquing power and back again. Depress the detent and rotate the arm up into the handle position. When you do so, a cam locks the tool into the high-speed position. In the high-speed mode, the socket rotates at several hundred revolutions per minute, but torque is limited so that the tool cannot spin or kick back in the operator's hands. Rotating the arm down into the plane of the socket locks the tool into the low-speed mode, and the arm becomes the reaction point for torquing. In this power position, the arm cannot spin at high speed. As a matter of fact, it will not spin at all, as long as the socket is free to turn. Now let's put the system into action. Let's suppose that the job at hand is to tighten these 1 1/4" studs with 2-inch nuts to 600 foot-pounds of torque, using the dual-speed flip gun. It is not our purpose here to discuss how torque values are determined. Click on the additional training icon in the table of contents for help in computing torque values or obtaining additional instruction on bolting principles. Since the turning force of the tool is determined by the air pressure supplied, we must consult the pressure-torque conversion chart for our specific tool to find out how much pressure to apply. Looking down the foot-pound column, we find 600 foot-pounds corresponds to 40 psi. With the tool on a stable surface, turn on the air supply and adjust the incoming air pressure up to 40 psi by turning the regulator knob. Always set pressure from lower to higher on the gauge. With the tool in high-speed mode, we are ready to run down all the nuts. The studs and nuts should be clean and free-running before any turning force is applied. By the way, only high-grade impact sockets should be used with the flip gun. Never use chrome or manual-grade sockets, as they could shatter, causing serious injury. Never use an oversized socket, as this can also be dangerous. Always pin the socket onto the drive. With the directional switch in the tightening position and holding the tool securely with both hands, quickly run the nuts down until snug against the flange. Flip the speed selection arm into the torquing position by rotating it into the plane of the nut. Engage the nut, turn on the tool, and observe the reaction arm turn until it butts up against the next nut. You can speed the work by pre-positioning the arm rather than waiting for it to turn. Never touch the reaction arm or the reaction surfaces while the tool is running. In order to protect the operator from inadvertently having his hands in the danger zone near the socket, the tool will not operate in the low-speed power position until the safety lever switch at the rear of the tool is depressed and held. Hold the trigger in until the tool stalls and will no longer advance the socket. You have applied 600 foot-pounds of torque to that nut, and every nut will get the same tightening force until you change the pressure on the regulator. Note, your bolting plan may require tightening in increasing steps. If that is the case, simply adjust the air pressure accordingly for each step. It is always a good practice to make a final check pass on all nuts because tightening one may change the achieved load in its neighbor. To remove the nuts, reverse the process, this time beginning in low-speed power mode with the speed selection arm in the lowered position. The effects of time and corrosion can make nuts or bolts more difficult to remove than they were to tighten. Since we don't care about achieving a specific torque value, turn up the air pressure to at or near its maximum, giving the tool its full power. Shift the directional control to the loosened side. Apply the wrench and position the reaction arm against the next nut, keeping in mind that the arm will now move clockwise, opposite the direction of the socket. Loosen all the nuts until they can be turned by hand. Shift the arm to the high-speed position and proceed to run off the nuts. The flip gun, the fastest torquing tool on the planet.